Good morning from a lovely overcast day in Johannesburg, South Africa, with a good promise of rain and a slightly cooler temperature than yesterday. Let's have a look at the first three rules of exponents. We've had a video already using multiplication and division of exponents, but we're now also going to go on to raising a power to a power. So looking at the first example, if we think of our rules of order of operations that we've learned right back from when we were fairly young, we know that we need to eliminate this bracket first, and then we'll be able to multiply. So actually, let's look at the bracket in more detail. So everything inside that bracket is being raised to the power of 3, and we need to do that first. But when we find that answer, we're still going to leave it in a bracket, simply because we also need to multiply the answer by the negative 6m squared. So the negative 6m squared is not ready to be used yet, so we write it down. And now we're going to look at this bracket raised to the power of 3. So if you're raising a number to the power of 3, then remember it means that you're saying 2 times itself times itself. So in other words, 2 times 2 times 2. So a lot of these powers you'll know off by heart by now, but let's just work through this one. 2 times 2 is 4, and 4 times 2 is 8. So 2 to the power of 3, or 2 cubed, is 8. And then if we're working with variables, remember that that's when we're really going to use the exponential rules, because again, remember this means m to the power of 1. So it says when we're raising a power to a power, we need to multiply the exponents. So we have a base of m, and it's going to be m to the 1 times 3, which is 3. We also have a base of n, and n is already raised to the power of 2, and now it's being raised to the power of 3 as well. So we say 2 times 3 is 6. So I've worked that part out. I no longer have an exponent outside the bracket. It's simply negative 6m squared multiplied by what's inside the bracket. So now we go back to our method of a 3 or 4 part thought process to get to the final answer. So we're going to say negative times positive is negative. Then look at the coefficients. 6 times 8 is 48. Then look at anything that's got a base of m. M squared times m cubed. Now remember, this has got its own base, and that's got its own base. So we're not raising a power to a power. We're multiplying a power by a power. So the base will remain m. And in this case, we're going to say 2 plus 3 is equal to 5. There is no other power with a base of n, so that is simply going to remain n to the power of 6. And that's our final answer. Let's look at something a lot more interesting than that. And let's look at brackets. Negative 4x cubed y to the power of 4, and we're going to raise all of that to the power of 2, and then we're going to have a denominator of negative 3 bracket negative 2 xy squared, all raised to the power of 3. So we have a lot of things going on in here, and I'm going to go through it very carefully and methodically so that we look at how all the different rules are applied. So obviously, we've remembered from so many videos now that this line means divided by. We can't divide the numerator by the denominator when they both have so much that they still have to have done to them. So we need to bring that into a more reasonable looking form, and the same thing there, and then we can look at dividing the two. So here I have everything in the bracket raised to the power of 2. So if I go through it step by step, sign, coefficient, and then the variables, I'm going to be saying, if it's raised to the power 2, then I've got to say a negative times a negative, which is going to give me a positive. My coefficient is just a straightforward number, so I'm going to say 4 times 4 is 16. And then remembering that with a base of x, I have to multiply its exponent by 2 because it's a power raised to another power. So 3 times 2 is 6. And then the same thing here, I have another base of y. It already has an exponent of 4 and it's being squared again. So 4 times 2 is 8. So that wasn't too tricky for the numerator. Let's have a look at what's happening in the denominator. Everything inside this bracket is being raised to the power of 3. That negative 3 is not affected because it's outside of the bracket. So because of order of operations, BODMAS, and we know that we have to do brackets first, that negative 3 is not ready to be used. When something's not ready to be used, don't just ignore it and leave it. You have to write it down. I call it putting it in your suitcase because you don't need it right now. You're on holiday, you don't need it right now, but you are going to need it later, so you put it in your suitcase for later. And now let's raise all of this to the power of 3. And remember, because after we get this answer, we're still going to multiply it here as well, we need to keep it in a bracket. So negative raised to the power of 3 means negative times negative times negative. So let's do that. Negative times negative is positive. Positive times negative is negative. 2 to the power of 3 means 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8. You probably know that off by heart. And then again, remember this is x to the power of 1. So I've got a base of x. 1 times 3 is 3. Here I've got a base of y. It's already raised to the power of 2. 2 times 3 is 6. And then I'm going to tidy up the denominator so that I can continue to the final answer. So because my numerator is sorted out, I write it down exactly as it is. I don't just forget about it. I write it down. I keep it with me. I keep everything moving down to the next step. This is an integer multiplied by a bracket. So again, let's start with the signs. Negative times negative is positive. 3 times 8 is 24. There's no variables here, so those variables aren't going to be affected. So it's going to be x cubed y to the power of 6. Right, so when I divide here, x to the 6 divided by x cubed, I'm going to be using my exponential rules. But with these coefficients, they're simply integers. In fact, these ones are whole numbers. So I need to just divide them in the normal way that I always do. And we can see that 16 doesn't go into 24. This is not a normal division situation that we've had in previous videos. So what we've got to do now is again look for our highest common factor because we want to simplify these numbers down. So 8 will go into 16 twice and 8 will go into 24 3 times. So straight away here, I can see that I'm going to have something left in my denominator this time. But those are now in its simplest form. So I'm going to have a 2 at the top. Then using my exponential rules for division, if I'm saying x to the 6 divided by x cubed, then I'm still going to have a base of x and I'm going to say 6 minus 3 is 3. Here I'm still going to have a base of y, and I'm going to say 8 minus 6 is 2. And then don't forget, because of this cancellation, cross cancellation that we did here, I still have a coefficient of 3 at the bottom. So here I have a situation where I have simplified this tremendously from what it looked like in the beginning, but I do still have a denominator in my final answer. What I really want to have a look at is this situation. Negative squared became a positive. Negative cubed remained a negative. So I want you to use that as the basis of your thought for any kind of situation where you have a negative raised to a power. So we saw that the reason this negative squared became a positive was because negative squared meant negative times negative, which is a positive. And the reason this negative cubed became a negative or remained a negative was because negative times negative is positive, positive times negative is negative. But what you've got to remember is that if you have a negative value and you're raising it to an even power, the answer will always be positive. And if you have a negative, which you're raising to an odd power, the answer will always be negative. So if you get a negative and it's raised to the power of 100, you just straight away know 100 is an even number, and so that is going to come out as a positive. If you get a negative raised to 77, for argument's sake, 77 is an odd number, so straight away you know that your answer is going to have a negative value. And that's some knowledge that you can project onto any exponent that you ever presented with.